All right, from the last video, we talked about graphing other types of rational functions, those that were not in this form that we did earlier. And we took a set of notes regarding vertical and horizontal asymptotes and where the zeros are. Now let's put this information into play. First of all, if P of x divided by Q of x is in reduced form, the graph has zeros where the numerator is equal to 0, and it's got vertical asymptotes where the denominator is equal to 0. So let's go practice that. I'm going to skip a couple of slides. Here's a chart with 3 different rational functions, and we're going to do all 3 of them. So if you'd like to pause the video and make this chart, please do. All right. The first one, letter A. X minus 1 divided by 3x squared. The zeros are where the numerator is equal to 0. Okay, so I just said x minus 1 equal to 0, and I solve it. And what I find out is x equals 1. 1 would be the only 0 that this function has. It's the only place where it crosses the x-axis. The vertical asymptote is where the denominator is equal to 0. Well, if I solve that and divide by 3, 0 divided by 3 is 0, and then if I take the square root of both sides, I get x equals 0. That is where the vertical asymptote would be. Now, let's go back a slide to our notes on horizontal asymptotes. Horizontal asymptotes depend on the degree of the 2 polynomials. So what I need to do is I need to list the degree of P and I need to list the degree of Q. So let's go back a slide. I'm going to write this in blue. The degree, and I'm going to abbreviate, the degree of P is the degree of the numerator. Well, the degree, the power of x is equal to 1. The degree of Q is equal to the power of x, the highest power in the denominator. That's 2. All right, so now let's go back a slide. The degree of P is 1, and the degree of Q is 2. So 1, the degree of P is less than Q. So since 1 is less than Q, the line y equals 0 is the horizontal asymptote. So I'll go back here, and I'm going to write that in green. To summarize, the line y equals 0 is where our horizontal asymptote would go for this problem. All right, let's try that again. Number 2. The zeros are where the numerator is equal to 0. X squared plus x minus 6 equals 0. Well, I'm going to have to factor this guy. That's going to come out to be x plus 3 times x minus 2, which is equal to 0. And by the way, I hope you can see, if you put that in the numerator, you'd see that this polynomial or this function's already in reduced form, because something on the x plus 3 and x minus 2 on the top cannot reduce with the x in the numerator. Okay, so therefore now, pretty simple. That part will give you x equals negative 3, and that part will give you x equals 2, and those are your 2 zeros for this function. The vertical asymptote, well, that's really simple. That's where the denominator is equal to 0. We don't have to do anything. X equals 0. That's where your vertical asymptote would be. Okay, now the horizontal. Let's talk about the degree of P, which is the numerator. The degree of P, the highest power, is 2. The degree of Q, which is the denominator, that power is 1. So now we go back a slide, and we see that the degree of P is 2, which is greater than the degree of Q, which is 1. Therefore, this graph has no horizontal asymptote. Since 2 is greater than 1, this one has no horizontal asymptote. Hope that makes sense. All right, the last one. This one we're going to have to factor. We got to put it in factored form. Well, the numerator would be x plus 2 times x minus 2, perfect square binomial, divided by, and I can factor out a 3, and if I do that, I'll have x squared minus 9, which is also another perfect square binomial. Oh, there we go. And nothing reduces, so it's in reduced form. So the zeros are where the numerator is equal to 0. We have x plus 2 and x minus 2 equal to 0. Well, that's pretty simple. So x cannot, or x equals negative 2, and for this one, x equals positive 2. Those are where your zeros are going to be. The vertical asymptote. The vertical asymptote is where the denominator is equal to 0. This one is going to have two vertical asymptotes. Now the 3 doesn't give us anything. 3 can't equal 0. But this part right here, x equals negative 3 is the first vertical asymptote, and x equals positive 3 would be the second vertical asymptote. And finally, the degree of p is equal to 2, right there, and the degree of q is equal to 2, right there. So go back a slide, and it says if the degree of p equals the degree of q, then we got to look at the lead coefficients, and that's our horizontal asymptote. All right, so our horizontal asymptote will be the lead coefficient of the numerator. That's the number 1. That's our lead coefficient, divided by the lead coefficient of our denominator, which is 3. So therefore, our horizontal asymptote is the line y equals 1/3. Hope that makes sense. All right, well, let's put all this information together and do one graphing problem. If you need to pause the video, please do and write this information down. All right, x squared minus 2x minus 3 over x minus 2. Let's make sure it's in reduced form and factor it. The top would factor into x minus 3 and x plus 1, and the numerator is x minus 2. Good, it's already in reduced form. The zeros is where the numerator is equal to 0. Well, this piece right here, x equals 3 would be the first 0, and this piece right here, x equals negative 1, will be the second 0. So we all know what zeros are from our quadratic equation days. 3 is one of the zeros, and negative 1, that green dot. The graphs have to go through those two green dots. The vertical asymptote is where the denominator is equal to 0. Okay, good. Well, if I solve that equation, x equals 2. That's my vertical asymptote at 2. So I'm going to put a vertical dotted line at 2. Now, do we have any horizontal asymptotes? That's where we need to look at the degree of p, the degree of the numerator, which is equal to 2, and the degree of the denominator, which is polynomial q, which is this 1 right here. Okay, now I got to go back 2 slides and check my notes. I forgot. The degree of p is 2, and it's greater than the degree of q, so therefore we don't have any horizontal asymptote. Okay, good. So this graph has no horizontal asymptote. Perfect. All right, good. So now all we got to do is make a t-table. Well, our error occurs at 2. So that's going to be in the middle of my chart. So maybe what I need is negative 1, 0, and 1 here, and then maybe I need 3, 4, and 5 right there. So why don't you go to your calculator, and if you take your calculator out, you're going to notice that negative 1 is 0, just like it says on our graph. We put a green dot at 0 already. 0 produces a value of 1.5. 1 produces a value of 4. 3 produces a value of 0, which we also have on our graph already. 4 produces 2.5, and 5 gives us the value of 4. All right, so now, if you plot those dots, which I'm going to do in green, negative 1, 0, 0, 1.5 is about right there. 1, 4 is about right there. So this side of the graph has got to go something like that. Now the right side of the graph, 3, 0, 4, 2.5, 4, 2.5 is about right there. And then 5, 4 is about right there. So the graph starts curving. It can't cross that dotted line. So the graph must look something like that. And if you wanted more accuracy, you could sure plot a few other points. People, that is how you use all this information to graph other rational functions.